Let us explore the core benefits of this circular sanitation thinking for people and the planet. Its contribution is that resources within the sanitation systems are harvested. Sanitation resource technologies evolve for recovery and reuse. New technologies are able to extract variety of resources from human waste. There is value creation and application of these resources from sanitation waste. It leads to decentralized sanitation solutions. The circular sanitation thinking around resource recovery from sanitation systems, it's about unpacking what resources are flushed down the toilet, how can the resources be recovered from the sanitation systems, and how can resources be recovered and reused. Let us look at this potential to sanitation value optimization, and it is dependent on the resource composition. Human waste is a resource. A person generates 400 grams of human waste per day. Of this, possibly includes 4.5 kilograms of nitrogen and 0.5 kilograms of phosphorus over the year, and possibly around 1.2 kilograms of potassium from one human being. The energy value of this feces over the year can generate about 4,000 kilocalories per kilogram. There is further a whole lot of other value-based products that can be derived from human waste in the form of urea, ammonia, sodium, potassium chloride, oxalate, and many other value-based products. So if you take this resource composition, this feedstock is great. At 400 grams per person per day, you're looking at a human species of around 7.25 billion people. The supply potential of about 2.9 million metric tons of feedstock per day, guaranteed, is significant feedstock to stimulate a whole new sanitation economy. Now let us share with you some of these value creation developments from sanitation in terms of products and resources. And these are real examples. The first example I'm going to take is looking at urine. And urine has several potential as identified. The generation of nutrients in the form of nitrates, phosphates, potassium. But as an example around how urine is being used as a contributor to the construction industry. Normally in the making of bricks, a lot of energy is used to harden the clay by burning it. But using urine has the potential in terms of the development of biobricks. And urine doesn't need any heating, it offers the binding property. But added to this, the urea in these bricks can also be used as a soil conditioner, because placing these bricks in agriculture offers the slow release of urea to the environment. Now, how this is made is that when you're processing the manufacturing of a brick, you add urine to the process, and what you get through a calcium carbonization process in a chemical reaction with the clay material is a biobrick, and the biobrick has the equivalent strength of a normal concrete brick. So these biobricks offer the potential of replacing clay and masonry bricks in the building industry. The second sanitation resource opportunity example I would share is that for agriculture through what we call the LADEPA process. Around the world, there are many on-site dry sanitation systems, and when these fill up, there is no opportunity of how to deal with the fecal sludges that are generated. The LADEPA is one such opportunity that offers the treatment of very high calorific value fecal sludges by treating and developing pellets that can be used in the agricultural sector. The technology is very simple. Through an infrared process, the sludge is dried, but also offers the killing of pathogens, and pasteurizes the sludge, which then is compressed into pellets, but still contain the nitrogen and phosphorus elements in those pellets. And these pellets are then used as a soil amendment or as a nutrient source in the agricultural sector. The third example I would like to share is the opportunity through a very simple technology also to treat and manage fecal sludges. Through this process, which is a pyrolysis process where human waste is heated to very high temperatures in a vacuum, the carbon element of the biomass is converted to biochar. There are advanced processes, but this simplified process generates a biofuel that can be used for cooking, as we have seen the industry flourish in Uganda, where biochar manufactured through this process is starting to be used as the preferred fuel in many applications. But the biochar can also be used as a soil remediation product. The fourth sanitation resource example I'd like to share is a very interesting one. It's about the black soldier fly, which is getting great attention globally. People think that black soldier flies are pests, but in their larvae stage, the black soldier flies are great machines in breaking down organic wastes. In their lifespan at a larvae stage between 30 to 35 days, they are very efficient in breaking down any organic matter, including fecal sludges. In the application of fecal sludges, these worms are able to generate 3 byproducts. The first is a soil conditioner or compost, which is rich in nutrients and can be used in agriculture as one of the byproducts. When these worms are harvested and dried, the residue husks or body contains very high protein that is useful in the animal husbandry environment as a feed, as a protein feed. The third byproduct is that when these worms are dried and they are pressed, you generate oil. And the quality of the oil is several times higher than palm oil, offering the opportunity to be used in many applications in industry. So this is how a very simple process is designed to contribute to the circular economy by beneficial byproducts and seeing urine and waste as a resource. So the fifth example I am sharing amongst several innovations around nutrient and energy recovery is that of the enhanced hydrothermal pyrolysis technology. In this process, a variety of sludges of different quality, both wet and dry, can be put through a process of pyrolysis through the enhanced technology process, under which between 180 to 240 degrees Celsius in about an hour or two, you can produce this biochar, but you're also able to create a liquid solid separation, and this supernatant that is generated can be recirculated as a catalyst to the reactor. But the byproduct in the form of this biochar is of high quality, and we call it a multi-use hydrostar. That is a green biofuel that can act as an absorption media. It also has a potential as a soil conditioner. It can be used in building materials. It is offering the potential for energy generation. And it is a material that can also be used in nanotechnology. So through these 5 examples, I've tried to demonstrate how technology and innovation is evolving in reality and through practical examples in the circular economy thinking of sanitation, in opening pathways around human waste being a resource. We will now follow of how once the technology and the innovation creates this platform of how the business models can be used to give effect to growing this market.